A hurdy-gurdy, but with a guitar fretboard. Can that be done? Let's find out. Hello and welcome to part 2 in this video series about building a hurdy-gurdy guitar. If you haven't already watched video part 1, I recommend you start out by doing that. This video will be about modeling the guitar in Autodesk Fusion and making the 3D printed fretboard. I was fairly new to Fusion when I began making this project, but I am a learning by doing kind of guy. So after having followed some YouTube courses like Learn Autodesk Fusion 360 in 30 days, highly recommended by the way, link in description, I just threw myself in the deep water. Woo! I found an old cheap Santana guitar, Danish brand by the way, where the bridge was lifted quite a bit, having ripped the top, so I felt okay with sacrificing this to my project. In hindsight, after having chatted with the hurdy-gurdy player Nigel Eaton, mentioned in the first video, I probably ought to have used an archtop guitar, which have a slightly arched top like violins and cellos and other stringed instruments, instead of a flat top. Because of the construction with a tailpiece, there is a lot of tension on the bridge, much more than on a normal acoustic guitar where the strings are fastened on the bridge. This can result in a collapse of the top. But since the strings on my hurdy-gurdy guitar don't rest on the bridge all the time, but hover over and are only pulled down on the bridge when playing, I'm hoping this will not become a big issue though. But something to keep in mind if I ever decide on building an improved version 2 of this instrument. This is not going to be a Fusion tutorial, but very briefly explained, I took some pictures of the guitar and used that as a canvas. Then I calibrated the size of the canvas with measurements taken of the guitar. From here it was pretty straightforward to draw the shape on the one side, mirror it, and then extrude the different components to make it solid. Lastly, I applied some wood texture with appearances to make it look more like an actual guitar. I did forget to take into account that the fretboard does not have the same thickness all over, but is actually a little bit thicker at the end of the soundboard. This mistake resulted in a lot of extra work. A lot. But more on that later. For modeling the fretboard, I used Austin Shainer's parametric fretboard. If you ever want to make guitars in Autodesk Fusion for CNCing or like me 3D printing, this is your go-to guy. Link in the description. With the parametric fretboard you can just type in different parameters or values and you easily get exactly the fretboard you want. I again use the measurements from the Santana guitar and then of course made sure that the radius of the fretboard corresponded with the radius of the hurdy-gurdy wheel. I then pasted the fretboard into the file with my model guitar using the align feature and aligned the angle of it to match the wheel. I then designed the nut according to the string thickness of the strings I wanted to use. I exported the whole fretboard and then cut it into pieces with dovetail assemblies in Orca Slicer before printing it. Then I started working on the guitar, removing the frets and the nut. And then sanding it down. I then cut the fretboard and used a 3D printed cutting template to angle the neck. Before gluing it back on. This was not an easy task, and as I have mentioned earlier, precision is not my strong suit. I then glued the frets on the 3D printed fretboard using some 3D printed helpers. Again, not so easy, and I had to re-glue and refit several times. I then fitted and glued the 3D printed fretboard onto the guitar using superglue. As mentioned earlier, I did forget to take into account that the guitar fretboard does not have the same thickness, but it's actually a little bit thicker on the side of the soundboard. This meant that the 3D printed fretboard was not completely straight. I did not want to redo all the work with modeling, printing the fretboard, gluing on the frets, and first having to remove them from the other fretboard. So I tried to fix it with making some gaps, aligning it, and then weld it together again with a soldering iron. This was very messy, but I did eventually get it to work. Then it was time to get the frets completely aligned using a file and an iron bar with different grids of sandpaper on it, and then making the frets rounded again with a fret file. Last thing to do was to get the fretboard more smooth. I did this by wet sanding it with finer and finer grids of sanding sponges, and finally polishing it with some lemon fretboard oil. Hope you have enjoyed watching this video. See you in the next part 3, about the wheel. Please consider liking this video, and if you want to follow my adventurous journey towards building this crazy instrument, don't forget to subscribe. Bye for now.